Virtual LAN Local Area Network, VLAN. A virtual local area network, or VLAN, is one of the most powerful tools in a network administrator's arsenal. To understand a VLAN, you must first understand the limitations of a standard physical network. In a traditional setup, every device plugged into the same physical switch is part of the same broadcast domain. This means if one computer sends out a broadcast shout, like a DHCP Discover packet, every single other device on that switch has to hear it and process it, in a large building with hundreds of computers. This creates massive amounts of noise or network congestion, which slows everything down. Furthermore, in a standard switch, a guest in the lobby is on the exact same network as the human resources server, which is a massive security risk. A VLAN solves both of these problems by allowing you to take one single, physical switch and carve it up into multiple, isolated, virtual switches. The architecture of logical isolation. The virtual in VLAN means that the separation happens in the software, or the logic, of the switch, not the physical cables. Imagine you have a 24-port switch. You can tell the switch that ports 1 through 10 belong to the accounting VLAN, and ports 11 through 20 belong to the guest VLAN, even though these devices are plugged into the exact same piece of hardware. They are now completely invisible to each other. A broadcast sent by an accounting computer will only be heard by other accounting computers. This creates multiple, smaller broadcast domains by reducing the number of devices in each domain. You significantly improve the overall speed and efficiency of the network. How it works: VLAN tagging and the 802.1q standard. When data moves inside a single switch, the switch simply knows which port belongs to which VLAN. However, what happens when that data needs to travel across a cable to a second switch in another room? To solve this, we use a process called VLAN tagging, specifically the 802.1q standard, when a data packet, or frame, leaves the first switch. The switch inserts a tiny tag into the header of the frame. This tag contains a VLAN ID, which is a number from 1 to 4094. The second switch sees this tag, reads the IP address and the VLAN number, and ensures the data is only delivered to the correct ports on its side. Once the data reaches its final destination, the tag is stripped off so the receiving computer never even knows it was there. Access ports versus trunk ports. To make VLANs work across an entire building, you must understand the two types of ports on a switch. First is the access port. This is where you plug in an end device, like a laptop or a printer. An access port belongs to exactly one VLAN. It does not use tags because the computer doesn't understand them. Second is the trunk port. This is a high-speed connection between two switches, or between a switch and a router. A trunk port is special because it is a member of every VLAN. It allows the tagged traffic from the accounting, sales, and guest networks to all travel across one single physical cable simultaneously without getting mixed up. Security and the router on a stick. From a cybersecurity perspective, VLANs are essential for network segmentation. By putting sensitive servers in their own isolated VLAN, you prevent an attacker who compromises a guest's laptop from pivoting or moving laterally to your private data. But what if an authorized accounting manager needs to access a file on the sales server? Since they are in different VLANs, they cannot talk to each other directly. To allow this, the traffic must go through a Layer 3 device, like a router or a Layer 3 switch. This is often called a router on a stick configuration. The router acts as the gatekeeper, checking the security rules or access control lists before allowing traffic to pass from one VLAN to another. This gives you total control over who can move between the different sections of your virtual network. By mastering the logical isolation of VLANs, the mechanics of tagging, and the security of segmentation, You will be able to build networks that are both incredibly fast and highly secure.